Welcome to Astronomy Daily, your quick dive into the cosmos with me, Anna.
And me, Avery. We've got some fascinating stories for you today, from our solar system's mysterious ice giants possibly being rock giants, to Blue Origin's next big launch, and some mind-bending theories about humanity's place in the universe.
That's right. Let's kick things off with a rather surprising reclassification for two of our own planetary neighbors. You know how we always refer to Uranus and Neptune as ice giants? Well, a new study is challenging that long-held belief.
Yeah, it's pretty wild. Researchers from the University of Zurich have been digging into their interior structures using advanced computer models and existing planetary data. And what they found suggests these planets might actually be rock giants instead.
Indeed, the implications of this study are quite profound. If Uranus and Neptune are primarily composed of rock, rather than the icy mixtures we've long assumed, it significantly alters our understanding of how these planets formed and evolved. This isn't just a minor tweak to planetary classifications, it could necessitate a complete reevaluation of models of planet formation in the outer solar system. For decades, the ice giant moniker suggested a composition rich in water, methane, and ammonia ices. However, the University of Zurich's research, led by Dr. Joachim Sauer, suggests a different picture. Their advanced computer simulations, which integrate various geophysical and astrophysical data, indicate that the pressure and temperature conditions within these planets are more conducive to the formation of silicates and other rocky materials than previously thought. This would mean that a substantial portion of their mass, perhaps even the majority, is in a solid rocky state deep beneath their thick atmospheres.
Absolutely, Anna. This groundbreaking research from the University of Zurich, building on the work of Dr. Joachim Sauer and his team, suggests a radical departure from the conventional wisdom. For so long, the term ice giants has been ingrained in our astronomical lexicon, painting a picture of these distant worlds as swirling masses of frozen water, methane, and ammonia. But if these advanced computer models are correct, then we're talking about a significant portion of their internal structure being made of much denser rocky material. Imagine a core that's not just icy sludge, but a solidified, high-pressure rock formation, hundreds of thousands of kilometers across. This would challenge our fundamental understanding of how planets accumulate material during their formation. Did they accrete more rocky planetesimals than previously thought? Or did some process during their evolution lead to a differentiation where heavier elements sank deeper and solidified under immense pressure? The implications are vast, not just for Uranus and Neptune, but for exoplanetary science as well. Many exoplanets are classified based on assumptions derived from our own solar system. If our ice giants are actually rock giants, then our classifications for distant worlds might also need a serious reevaluation. It's a truly exciting time for planetary science as new data and sophisticated modeling techniques continually push the boundaries of our knowledge. This reevaluation of Uranus and Neptune's composition opens up a fascinating new chapter in planetary science. It forces us to reconsider the very definition of a giant planet and how these colossal celestial bodies are formed. Traditionally, models of planetary formation focus on two main pathways: the core accretion model, where a solid core forms first and then attracts gas, and the disk instability model, where portions of the protoplanetary disk collapse directly. If Uranus and Neptune are primarily rocky, it might suggest a more robust role for rocky planetesimals in their formation, or perhaps a different evolutionary track where significant amounts of lighter elements were lost over time. This could also shed light on the diversity of exoplanets we're discovering. Some exoplanets classified as mini-Neptunes or super-Earths could potentially have compositions similar to these newly theorized rock giants, blurring the lines between these categories. The implications are truly far-reaching, extending beyond our solar system to the broader understanding of planet formation across the galaxy. It's a testament to the dynamic nature of scientific discovery, where even long-held beliefs about our cosmic neighbors can be challenged and refined by new data and innovative theoretical frameworks.
Now, let's shift our gaze from the depths of planetary interiors to the exciting frontiers of commercial spaceflight. Blue Origin, Jeff Bezos's aerospace company, is once again making headlines with its preparations for another significant launch. These missions, while often appearing routine to the casual observer, are critical steps in expanding humanity's access to space, pushing the boundaries of technology, and ultimately making space travel more accessible. Blue Origin's New Shepard suborbital vehicle has been a workhorse for short trips to the edge of space, carrying both scientific payloads and private astronauts. Each launch provides invaluable data, allowing engineers to refine systems, enhance safety, and prepare for even more ambitious endeavors, like their New Glenn orbital rocket, which aims to deliver heavier payloads to higher orbits and eventually support lunar missions. The iterative nature of these launches is essential. Every flight, even seemingly minor ones, contributes to a growing body of knowledge that fuels future innovations and brings us closer to a sustainable presence beyond Earth. We often focus on the spectacle of human spaceflight, but the unsung heroes are often the scientific experiments and technological demonstrations that ride alongside, gathering data in microgravity and testing new systems that will power the next generation of space exploration.
Indeed, Anna. Blue Origin's strategy, much like that of other private space ventures, is a testament to the power of incremental progress. Each New Shepard flight, whether it's sending scientific instruments to conduct microgravity research or taking private citizens on a brief but unforgettable journey to the Kármán line, is a building block. These suborbital hops are not just about spectacle, they are vital testing grounds. They allow engineers to gather real-world data on everything from propulsion systems and structural integrity to crew safety protocols and landing precision. This data is then fed back into the design and development of their more ambitious projects, particularly the massive New Glenn orbital rocket. New Glenn, with its immense payload capacity, is designed to launch satellites, interplanetary probes, and even components for future lunar landers and orbital habitats. The vision extends far beyond just getting to space. It's about creating a sustainable, accessible infrastructure for human activity in the cosmos. And it's not just about the rockets themselves. Blue Origin is also deeply involved in developing engines, such as the B-4, which powers both New Glenn and United Launch Alliance's Vulcan Centaur rocket. This kind of intercompany collaboration and shared technology further accelerates the pace of innovation in the space industry. It's a truly exciting era, where the dream of widespread space access is slowly but surely becoming a tangible reality, driven by these relentless efforts in engineering and iterative testing.
Absolutely, Avery. The commercial space sector, spearheaded by companies like Blue Origin, isn't just about sending rockets skyward. It's about democratizing access to space and fostering a new era of innovation. Think about the ripple effect. As launch costs decrease and capabilities expand, more research can be conducted in microgravity, new industries can emerge, and eventually, more people will have the opportunity to experience space firsthand. This isn't just a distant dream, it's a tangible future being built with each successful mission. The pursuit of sustainable space infrastructure, from orbital hotels to lunar bases, relies heavily on the foundational work being done now. Blue Origin's vision, Grata Team Ferocity, step by step, ferociously, perfectly encapsulates this methodical yet ambitious approach. They are not only building rockets, but also developing the underlying technologies that will make sustained human presence in space a reality. This includes advanced engines, reusable launch systems, and even conceptual designs for space habitats. It's a long-term game, but one with profound implications for our species. As we look outwards, the very act of exploring and expanding our reach into the cosmos inevitably leads us to ponder our own existence, our origins, and our ultimate destiny. It's a journey that forces us to confront some of the most profound, mind-bending theories about humanity's place in the universe. From the vastness of the cosmos to the intricate dance of fundamental particles, the universe seems to whisper questions about our significance, our uniqueness, and whether we are truly alone. These are not merely philosophical musings, but deeply scientific inquiries that drive much of our astrophysical research. The search for extraterrestrial life, the study of exoplanets, and the exploration of dark matter and dark energy all contribute to our evolving understanding of where we fit in the grand cosmic tapestry. It's a humbling yet exhilarating realization that our journey into space is intrinsically linked to our quest for self-knowledge. Each discovery, whether it's a new exoplanet or a deeper insight into the early universe, reframes our perspective and challenges our anthropocentric views, pushing us to imagine possibilities far beyond our terrestrial confines. Shifting gears from philosophical quests, let's talk about some fascinating new findings from Mars. European Space Agency orbiters, Mars Express and ExoMars Trace Gas Orbiter, have been busy mapping dust devils on the red planet.
That's right, Anna. Over 2 decades, researchers tracked an astounding 1,039 dust devils, and what they found is pretty remarkable. These Martian whirlwinds can actually reach speeds up to 98 miles per hour or 158 kilometers per hour, which is much faster than we previously thought.
And this isn't just a cool fact. These findings are incredibly important for future Mars missions. Understanding how these dust devils behave helps us plan better, especially when it comes to the impact of dust on rover solar panels and the selection of safe landing sites.
It's also a testament to innovative tech, as artificial intelligence played a key role. AI was used to analyze how these dust devils shifted between frames, essentially turning what might have been dismissed as image noise into valuable scientific measurements of wind speed and direction.
The data also revealed some interesting patterns. Martian dust devils are most frequent during the daytime in spring and summer, typically peaking between late morning and early afternoon, and they usually last only a few minutes.
What's particularly significant, though, is how Martian dust behaves compared to Earth. Here, dust settles relatively quickly, but on Mars, dust can linger for months. This makes understanding its uplift mechanism critical for predicting the planet's weather and even its long-term climate.
Exactly. This new global data is invaluable. It's helping scientists refine atmospheric models and significantly improve future weather forecasts for Mars, which is crucial as we look towards more sustained human presence there.
And it's this profound connection, Anna, between our exploration of the cosmos and our internal philosophical quests that makes astronomy so endlessly captivating. Every new mission, every telescope image, every theoretical breakthrough serves not just to fill our scientific journals, but to enrich our human experience. It makes us question, imagine, and ultimately understand ourselves better in the grand scheme of things. From the subatomic to the supercluster, the universe is a symphony of mysteries, and we, as curious observers, are both part of the music and its eager listeners. As we continue to delve into the vastness, we're not just finding answers about distant stars and galaxies, but also discovering more about the intricate, evolving story of life itself and its potential both here on Earth and perhaps far beyond. This ongoing dialogue between the known and the unknown is the very essence of discovery, constantly inviting us to expand our perceptions of what's possible.
And that's it for today. Thank you for coming along with us on our cosmic journey. Join us again tomorrow for more insights into our incredible universe on Astronomy Daily. Until then, keep looking up.